Planetary Causal Inference. PCI is a field where we draw on experimental, observational, or natural experimental data from social, natural, and environmental sciences and link those sources to satellite imagery or other Earth observation (EO) data. This integration with satellite imagery allows us to capture rich contextual factors for characterizing causal heterogeneity, modeling confounders, and imputing outcomes. The applicability across the applied sciences is wide-ranging, with applications in policy analysis, economics, and environmental science, to name a few. This post asks, what are the future directions in planetary causal inference? Short-term directions. 1. Multi-scale dynamics. One promising frontier lies in understanding multi-scale dynamics. This involves examining how household-level information, such as income, education, or local environmental factors, can be combined with more macro-level data from regional or even global satellite imagery. Bridging these scales can illuminate how micro and macro-level processes interact to influence causal relationships. For example, if large-scale satellite imagery shows evidence of drought or deforestation, how do these more macroscopic environmental changes affect specific households' welfare or economic outcomes? 1. 2. Model uncertainty and debiasing. Another critical area at the cutting edge is handling model uncertainty and integrating downstream predictions with debiasing techniques. Continent-wide or even global predictions often use satellite imagery to project poverty or health indicators, possibly across an entire continent by training on existing datasets such as the Demographic and Health Surveys (DHS). Even with best-in-class models, uncertainties can propagate and potentially bias conclusions. Furthermore, when random sampling of labeled data is infeasible, novel debiasing methodologies are needed to detect and correct systematic biases, ensuring that predictions remain robust at scale. 3. Multimodal integration. Multimodal integration is a third frontier that seeks to combine diverse data sources to maximize heterogeneity in analyses. By merging surveys, satellite imagery, administrative records, and other geospatial sources, researchers can identify variations in treatment effects across different populations or regions more effectively. This approach strengthens causal inferences by drawing on distinct yet complementary data channels, each contributing unique contextual insights. Long-term horizons. One significant longer-term horizon involves leveraging inference time compute within geospatial AI in PCI analysis. While these breakthroughs have shown great promise in areas like text generation, their applicability to satellite data and environmental research requires adaptation and careful validation. Another horizon involves the availability and ethics of high-resolution satellite imagery. Currently, limited access and high costs constrain our ability to explore deeper heterogeneity or detect more subtle confounding factors. Democratizing such imagery could broaden the scope of causal inference in environmental and social contexts, although privacy and ethical implications must be considered. Taken together, these directions, multi-scale dynamics, model uncertainty handling, and multimodal data integration, position PCI at an exciting place. Advances in satellite technology and inference techniques in vision models will likely further expand the field, enabling more precise understanding of causality on a global scale.